Have you ever wondered, where did everything around us come from? How did the universe begin? Let's take a moment to ponder on these questions that have intrigued humans for centuries. The vast cosmos we inhabit, with its celestial bodies and infinite expanses, didn't just appear out of nowhere. There must be a beginning, a starting point. Enter the Big Bang Theory, a scientific explanation that has gained wide acceptance. It's a theory that takes us back billions of years, to the very moment when everything we know and see, and even the things we can't see, came into existence. It's a journey to the origins of space, time, matter, and energy. The Big Bang Theory isn't just a story about the past. It's a narrative that shapes our understanding of the universe, the world we live in, and our place within it. The Big Bang Theory tries to answer these questions. It explains the inception of the universe from a singularity, a point of infinite density and temperature. Imagine all the matter, energy, space, and time in the universe packed into a single, infinitesimally small point. That's the starting point of the Big Bang Theory, a concept that's often misunderstood. Let's simplify it. Picture yourself holding a balloon. This balloon represents the universe, but it's not the balloon itself we're interested in. It's the surface. Now imagine dots on the balloon. As you blow it up, the dots move apart. This is how the Big Bang Theory describes the expansion of our universe. The term Big Bang can be a bit misleading. It wasn't a colossal explosion in the middle of nothingness. Instead, it's more accurate to think of it as the rapid expansion of space itself. This expansion started from an incredibly hot, dense state called a singularity. A singularity, in the context of the Big Bang, is a point of infinite density and infinitesimal size. It's a concept that defies our current understanding of physics. This singularity didn't exist in space because there was no space until after the Big Bang. From this singularity, our universe began to expand and cool. It's somewhat like when you bake bread. The dough starts as a dense mass and expands as it bakes. The same thing happened with the universe, although on a vastly larger scale. As the universe cooled, it went through various stages. One of these stages, known as recombination, saw the formation of neutral atoms for the first time. These atoms then began to clump together under gravity, forming stars and galaxies over billions of years. And so, our universe as we know it today began to take shape. From an unimaginably tiny, dense point to an ever-expanding cosmic expanse, brimming with galaxies, stars, and all forms of matter. So, from this singularity, the universe expanded and cooled, leading to the formation of atoms, stars, and eventually galaxies. The Big Bang Theory is not just about a massive explosion. It's much more complex and fascinating. This theory is a cosmological model that offers a comprehensive explanation about the universe's birth and its evolution over approximately 13.8 billion years. So let's delve into the key points. The Big Bang Theory suggests that the universe began as a hot, dense point nearly infinitely small. It was not an explosion in the traditional sense, but rather an expansion. A moment where the universe started to grow from an incredibly tiny, incredibly dense point into the vast complex cosmos we know today. But how do we know any of this? Well, the Big Bang Theory is supported by a multitude of evidence. One of the most compelling pieces is the detection of the cosmic microwave background radiation, or CMBR. The CMBR is a faint glow of heat left over from the early universe that permeates all of space. It's like the afterglow from a spectacular firework display, still visible even after the main event has ended. Another compelling piece of evidence is the redshift of distant galaxies. When we observe far-off galaxies, we find that their light is shifted towards the red end of the spectrum. This redshift suggests that these galaxies are moving away from us, giving credence to the idea of an expanding universe. However, the Big Bang Theory is not without its limitations and unanswered questions. For instance, it doesn't explain what caused the Big Bang or what was happening before it. It also doesn't fully account for the mysterious dark matter and dark energy that seem to make up most of the universe. Despite its complexities and unresolved questions, the Big Bang Theory remains the best explanation we have for the beginning and evolution of our universe. The universe is a grand cosmic mystery, and we are all a part of it. This vast, beautiful expanse of space and time is filled with enigmas that continue to baffle and amaze us. Despite our leaps and bounds in scientific knowledge, there are still countless questions that remain unanswered. But don't let that discourage you. Instead, let it ignite your curiosity. Because remember, every question you ask, every answer you seek, brings us one step closer to unraveling the cosmic mysteries of our universe.